SumaFlow end-to-end neural news summarization. This is an NLP final project presented by 聂岩、毛家伟、王歌远、周家乐. This is our agenda. Introduction and motivation. The volume of daily news is immersive, so we decided to build a model that can generate accurate and concise summaries of news articles. This is our approach by model dataset and data standardization. Model architecture, mini-BART. We use BART as the base model for this project. In order to balance efficiency and performance, we modified some of its default config to make it mini. The hidden dimension changed from 762 to 512. The encoder and decoder layers changes from 6 to 4, and thus the parameters shrinks from 140 M to 50 M. We use the CNN Daily Mail as our dataset, which is a widely used benchmark dataset for text summarization. It contains over 285,000 news articles and their corresponding multi-sentence summaries. The challenge is that the raw text is very noisy. It may contain reported bylines, timestamps, ads, and other boilerplate text that is not part of the actual article. So to address this issue, we present a stage of data standardization, which consists of 3 parts. The first part is data cleaning. At this part, we applied basic normalization, which catches common text issues, includes character encoding fixes, and junk character removal. The next, we also include sophisticated boilerplate removal, which removes text such as bylines, timestamps, calls to actions, contact information, and source prefixes. The next part of data standardization is filtering quality control, which also referred as the correlation stage. At this stage, we first apply the length-based filtering. It discards pairs where the article or summary is too short or too long. This is crucial for efficiency, since it avoids processing excessively long articles that would probably be heavily truncated anyway. It also helps quality, since it removes trivial examples that provide little learning signal. Also, we applied deduplication. It calculates an MD5 hash of a lowercase article text and drops any duplicates. This prevents the model from being biased by overrepresenting a few articles that might appear multiple times in the raw dataset. We also applied n-gram overlap filtering, which ensures the summaries are truly abstractive rather than extractive. It has a coverage check, which ensures the summary is actually about the article. It also has extractive content check, which is a high 2-gram overlap is a very strong indicator that entire sentences have been copied directly from the article. By filtering these out, the model is forced to learn from examples where the summary was genuinely rewritten. The final part of data standardization is data augmentation. The first of this part is sentence level augmentation. With a set of probability, the order of sentences in the source article is randomly shuffled. The purpose is that it forces the model to identify the most important information, regardless of where it appears. It discourages the model from developing a simplistic, just summarize the first paragraph strategy. This part also applies a token level augmentation, which applies a combination of 3 noise types directly to the token IDs of the source text, mimicking the original BART pre-training strategy, but with lighter intensity. Such strategy will have including masking, a token is replaced with the mask token. Deletion, a token is completely removed. And swapping, two adjacent tokens are swapped. Regularization. Okay. When training our bot model, we noticed that the validation loss stayed high, meaning the model was overfitting. To address this, we tried several regularization methods, like dropout, attention dropout, and activation dropout to reduce co-adaptation, as well as weight decay to control parameter growth. We also tested label smoothing, which helps reduce overconfidence, and compared the consign versus linear learning rate schedules with PROMAP. Some combinations worked well, others did not, showing that there's no single best choice. Regularization is really about balance. And too much is learning, too little is too overfitting. Inference. During inference, we can control the generation process in several ways. Beam search helps find more fluent outputs by exploring multiple decoding paths. We can also use no repeat n-gram size function to avoid repetition, and a length penalty to balance between shorter and longer summaries. Alternatively, temperature sampling can make outputs more diverse and more focused, depending on the value we choose. In short, inference is about balancing quality, diversity, and coherence in final text. Okay, here comes our demo. We made a website interface for our demo. If we can just paste news and we click generate summary, it will give us a very concise one-sentence summary, which is nice. And then we also have several modes for a model. We can have a beam search mode. You click generate, and you give us the top K summary is generated based on the score from high to low. If we set the K to, from 3 to 4 or 5, okay, you can generate, yeah, it will now give us 5 best results. We also implement a sample mode. Yeah, the model give us 5 best samples, and we can choose which is the best one. We also implement some other advanced parameters. Changing these parameters will give us slightly different results. The result. New evaluation standards. Since news summarization is inherently subjective, making it difficult to assess using simple comparisons or objective evaluation system. To address this, we introduced the large language model Gemini 2.5 Pro to act as a large language model judge. We employ the AS race, which specifically is summarization reference-based adaptive criteria-driven evaluation framework, which consists of 4 steps. First is define evaluation dimensions. Second is dynamic weighting and adaptive criteria generation. The third step is reference-based comparative scoring. The fourth step is final score calculation. The details can be referred in the report. The core of this framework is to transform the judge large language models evaluation from a subjective impression score into a structured, comparative, and quantifiable scoring process. This is our result. Yes, the 4 dimensions. Faithfulness is information in summary supported by a source news article. Comprehensiveness, does the summary capture the core points of the source article? Third is succinctness, is the summary sufficiently concise? Lastly, readability, Is the language of the summary fluent, coherent, and easy to understand? Okay, based on our evaluation metrics, if the final score is greater than 0.5, the judgment is considerably to be superior to the standard summary. If the final score is 0.5, then the quality of both summaries is considered equivalent. If the score is below 0.5, the model summary is considered inferior to the standard summary. And according to our result, our final score is 22.5, or in other words, 0.225. Our model did kind of okay. Result analysis. The model has effectively learned the demands of a summarization task. Its generated output shows nearly 50% similarity to the gold standard summaries, which demonstrates that it is successfully executing the task and approaching the quality of human expert written references. While the model can produce valid news summaries, there is still a clear performance gap between compared and to the gold standard answers.